Alright, morning Mallow Cups. Ready to do some math today? We're going to get it out here with Leonard. I'm actually been tracking my own thesis on this. I like Leonard for the work. It has little or nothing to do with mathematics, but as you will see throughout the presentation of this video, you're going to find it has a lot to do with math. This formal structure, whether it be velocity, acceleration, tensors, what do you got here? Correlations, you got vectors, tangents, tar, whatever it may be, you're going to find out that this is more important to try to put a subject matter into a functional piece. Now, one of the things about mathematics before we get into this class, the velocity and acceleration, is one of the things you guys got to understand about these classes. It takes a little practice to be able to sit down and actually watch a half-hour video or be able to process something like Pensrose 45-minute videos. It's a specific class type. Remember, a lot of this stuff you're going to get into with Leonard is, especially in my classes, I really don't care if you pay attention to the math and you use these forms for the psychology, certainly for mathematics. While he is teaching you the variable inside here, you have to pass the test. This is a ball in air, ball in water, it's a ball in air. It falls at 9.8 meters per second. So when you have a grade of A, that's going to fall at the most common right-hand rule of velocity and accelerations to 9.8 meters per second. And here on this planet of students, it's really super critical to do this. One of the more beneficial ways to look at this class is not for mathematics, but as a indicating subject matter to how to process students. So one of the things before I get up here, we will be getting into this. I watch at least one of these every night. I'll watch one from Stanford. I try to watch one from another college. I want to get as many sources as I can to determine whether they truly have the same velocity and acceleration or not in mathematics, and oftentimes you do. You will find that that's what they do. Sometimes you find people with great psychology tricks. Some people are very analytical about describing the board and carrying tones with just the information on here. And of course, Leonard out here, he's going to hit you with some of those numbers. Now again, from my dean's position, I'm looking at this from the NP problem, organization of field theories and students, and obviously you can see some of the tension that certain students are going to have with not having a professor at this point alone, because we are talking about the college as a whole here, of all the classes that add to one portion in something that looks a lot like reality. And I barrel this down the pipes with business models. It's a very tried and true methodology in a safe place, and in a way to handle what forms look like, what the brackets and sectors of cut coefficients, crew dynamics, maintenance service times. They're all going to have velocities, they're all going to have accelerations, and we're going to use those Bernoulli congruent A equals A2 Bernoulli's equations to then first go through them here, and then some point in time in life, when you guys get out there, whether your own business, whether you're working for somebody, your own business, whether you're working for somebody, or if any of the situations, you're a teacher, that's a job. A college, you got to find yourself in which version of that number game does the actual prediction or probability game actually play out to the matrix of the FMA ball that you're sending. So a lot of you students aren't going to get a lot of that in this early thing. Remember, this is not the first day Calculus 3 and how to understand it. Hopefully you would notice those students are built more formally up to this point, but you will still hear some of it.
Sometimes. So, new section.
Sigma. You still hear sigma some of it.
Velocity acceleration. Here's the beautiful thing about this section. This works exactly like Calculus 1. So the way you found velocity, instantaneous velocity, how do you go from position function to instantaneous velocity? Tell me what it is. Same thing here. How do you go from velocity function to instantaneous acceleration? Derivative, or second derivative of position. Same thing happens here. How about speed? What's speed related to? Position, velocity, or acceleration? Related to velocity, how do you go from velocity to speed?
These electrons pair themselves with electrons having spins opposite to this.
Not only do these states have singlet state, but also this event happening in the class. And it's a way that we can use to describe this, but without using spin. Here we can use velocity and acceleration, but it makes it real. And one of the problems with that is, sitting in this class, it's hard to perceive velocity. It's hard to perceive the acceleration, and therefore what the distance and the trajectory of this schematic will be. Right? But we're here to design schematics. We're here to design multiple forms of this, because this is obviously not an FMA ball of velocity and acceleration of a form type, right? Whether it be psychology, engineering, mathematics. Engineering is a velocity. It's also an acceleration. Mathematics is a velocity. It's going to give me a motion and a position. A train, a tan, a cosine. A value that we present to that system then gives enough for a singlet state inside of these forms, just like the interaction between students. Just like oxygen, nitrogen in the atmosphere in this box. That's going to be the spin on this example. First, we have to idealize that all is zero, is neutral in a perfect state, and within some generalizations of this page over here. Now Leonard, again, he's going to hit. Let me go back, turn this off here. Okay, so we can definitely use that, and that math is true. I don't want to argue with particle scientists because they're freaking particle scientists. Those computers output numbers. If I had to touch the buttons,
you guys were right. For velocity to speed in
this is the same terminal.
We just say, well, it's the absolute value, and that works fine. But here,
oftentimes, this is a little different. This one's a little easier than some of the other classes Leonard's are doing, but this is still friction. What he's going to have a problem with is the students, is I'm so far off the course. I know what he's doing. Let's assume he's the boss in the stone mill. I'm a good worker. He's trying to explain something to a trainee. Does this explain a singlet state of something that feels normal around here? Now, I don't want to bag on Leonard too much. We all have our phalanx in some subject matter or the other, and he has tenure. There's going to be things I've studied of other teachers from this position where I get to have the luxury to sit back and plunk some rabbits on Leonard. Of course, he's not going to be here to see me, hear me, and if the reactions of standard models still hold to be true, it's probably going to be very awkward. And every once in a while, again, short of everybody here understand or agree with that, which is at some point inside of here, an ability to say, let's talk about the for a vector function RT. And so we're giving up velocity and acceleration here. We're saying that instead of v being velocity and acceleration, we are taking a very different route. Here we are saying the rho is the velocity or the radiant or something under that time aspect is now truly idealized inside of the system. He's not giving you that. He's giving you the form. He's giving you to say later on there are multiple of these. I don't know which ones of students you come off great with later, but if a grade come off later, I could pick the motion acceleration because I know you're really good with vectors. I know you're really good with velocities and accelerations, and I remember that by putting a prime system in this variable. And it does not matter what class you teach. Could be literature, could be botany. Those all share the same velocities and accelerations, but we're not putting them up on the class because as a school, I'm sure you all have other classes that will need this. The phalanx in that is a two-part problem.
Relate it back to the things we were doing.
And you'll find that off of a three-part problem. But
he's
one man. I'm one man.
The second step in finding the unit tangent.
And two, the reality of the common core of a teacher in New York and a teacher in California have two different systems. And it is a little competitive because without somebody determine, oh yeah, well, Einstein's field theory right here, the danger noodle, the intergraphing system, particle through the earth, around the earth, goes into all these snowflakes of the velocity of sound waves through the core of the earth to figure out what its composition is, so when the particle passes through that stuff where you have to shoot it through there, it's going to make collisions, or you have to line it up in such a way that it does its dance in the field theory through all that without touching anything, and then to say around atmosphere, and that's going to give you the real field theory equation, but it's not going to give you a real value.
Take first derivative.
Right? Not off the front. You have to then process all those snowflakes, all those cells, not just of what it is right now, but how somebody perceived that graph. And the beautiful thing about math is it's going to come off that way. It's going to be a grid of some type. You could call your vector positions velocities. You could call them accelerations. You could call them positions. You could call them values on some form, space and time. And those space-times are going to change. It's going to be a snowflake. It's going to be Feynman diagram snowflakes. Very undertone. Well, firstly, people don't understand Feynman. They have a handler lead that's more better with velocity and acceleration. A lot of these students have to understand it as well. You're going to be a boss, you're going to be an employer, or you're going to be a monkey. It's really hard to be anything outside here, even if it's a private boss by yourself. You don't need employees, but you will be doing this number. It's how did you keep track of it? Well, take that simplicity and really make it formal.
That velocity is a vector. Is that weird or not?
Say I could train or something. Say these classes change the velocity that these students go. They say the in flight they are changing because you are, but there's still velocity. Going to increase or change direction, which knuckles. We're talking about the density of the air and the windage. These are the particles that you got to hit, and these are mathematically particles that no matter how it diverges, it does it. So formally, it takes time before you get Lagrangian Engel value, well not Engel value, Hamiltonian, Planck, all those things. Those are all individuals that they really cover a field. However, they are just in velocity and acceleration.
If I want you to find just velocity, acceleration,
amplitude, frequency, vibration. Those are particle systems in E, negative E. We're just quantifying a system as E to give me the snowflakes in cellular versions that then you can add together. And it gets very heavy about trying to
just finding at this point, plug it in here, find the speed of this guy.
Trying to organize the stone mill. And not just one stone mill. Sometimes it's practical to take 3 or 4 of them and add them together in one straight line, where I still was the ground guy, I still was the operator, then the sawyer, then a master mason manager, right? Because it's hard to argue, even though you're not getting the pay. I know, I just want to be the new Mew on all the, all right, Doomslayer, but inside of here, it's having it done gives you a capital advantage. Knowing it from here, I used to sit behind these classrooms and say, da 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 da, all the shit that I used to say until I had one. The advantage of somebody giving you one is you don't have to argue with Pensrose. You don't have to argue with Carl Sagan or Feynman. These are safe ways to do that variable. And over the tenure, you gotta remember, last year's students, they graduated. They probably have businesses and things right now. You'll have something to communicate with, or you'll understand how to graph a velocity of a project. Is this yours? Did you have an employee like that? Now, and certainly you can use events from the past, but that's not for this moment. You can use that input later, because how do you tell me that it won't happen in the future? Now let's change out the parts on that equation with Bernoulli's a little bit here and figure out the congruency of it. It happens. It does. Especially a lot of the male and women stuff in here.
You can plug in T here and find the magnitude, it will give you speed. But you can't plug in T here and try to find acceleration from here. Because if you try to take a derivative right now, what are you going to get?
Well, let's put the apple in the air.
It doesn't work.
I can tell you speed. It's off the ground this far. I have reciprocals of this test. That's what tells me the speed in which it is. But if it's anywhere else on that arc before it starts to fall down, then I can't really gauge its acceleration yet. It's still an approximation of increasing at this position. And of obviously, without bringing up Heisenberg's uncertainty equation here, in lieu, we can do it in a different form. And in Leonard, in lieu, we can apply that value to have a different set. Remember, as much as the teaching methods are around, one of the things that makes math and science so critical is that Heisenberg himself is not here to teach me this class. I have a full class that, well, I couldn't. You cannot bring Heisenberg to the table. Have to be done a different way that is congruent and acceptable to the system. Now, as far as the Lagrangian standard model is concerned, these are easier ways to do it. And not only is it easier to do it, you will find that when he takes velocity, when he takes acceleration, he's making it all to be this system. It looks hard, but I'm going to put this all into a 2x2 brick on one page with most of them. Now, I'm not going to do it here, but that's what it looks like. Okay? This is a half a page. For me, this is why it gives me a little bit of trouble, because I'm not going to say, when you look at the treasure chest here and you know where this is going, you know it's deep no matter which way you go. Is it worth dragging that treasure chest around here, or something that's got the NTF value on a blockchain chain rule that applies the same way to the born-in function of the born-in rule mathematically of being applied in 2020, or just walking into Leonard's class, walking into the stone mill, walking into the insurance company to get a business design, apps, their velocities and accelerations on a test. As students here, you know where most of those tests come up in the world, right? It's going to be quarterly, final exam, and every day. Well, out here, you don't really have the luxury of anything formal to be a test. Stuff breaks. Did you know the velocity and acceleration, are those acceptable on the three paths that you can go? They make the joke about the goat in the Ferrari game, TV game back in the day, and human intelligence of odds are if you pick this one and it's not, and you knew which ones you were going to pick in order, if you actually change it, you're statistically more likely to hit the car. Something about the brain in some games like that. So we're trying to figure that out. And what that is this mathematics. No matter which door I choose behind, I'm going to start to get a vector position. I'm going to start to get a P, a point or row for gravity inside here. We're going to do the math on there and apply that into Planck's shortest measurement. But one of the things you got to remember about these classes is again, because human nature is a phalanx inside here, even Leonard over here, that, again, some of the difference between the megaparsec 63, it's the right answer. 73.3 megaparsecs of the distance or the speed in which the universe is expanding can be something between two different teachers at the same time on the planet and other teachers before you guys are ready or anybody else signs the X right now. This is a terminal. How well you use that terminal or process the values of all these points might be different. And short of you being the teacher here, Leonard, I don't have the experiment, going to that other building and conducting the exact same experiment to get 73 or 63, it's almost impossible.
You know,
they should. That's the point.
How fast or slow.
The beauty about this kind of math is you don't need that horse shit.
I'm focused more on the concepts. Do you understand the relationship between velocity and position?
You don't need the drama of two teachers that aren't going to change out places and work things, but you can still work out the math. You don't need people's opinions to do this. You don't need stress realistically. It'll stress you. I don't need to wait for somebody's opinion. I can use dimensional analysis to fill this in and process it, and then look at the answer to say, did that happen, and then change that value to really give it the form that it was. But sometimes you get locked out if you can't add the other numbers in, or you're waiting on a boss to give you something. It's one of the things you don't need to worry about here. It's just when Leonard's not in the room, you can just blow through that. You can choose to say, well, any form of these models I like. I can combine multiple forms of them. Doesn't make them something you can test later. There's no way a kid's going to remember that system. But through Lagrangian, derivative L, we get a chance to and talk to the code. But if there was anybody else that knew that, they're going to stand out, right? Just like a kid that didn't know.
Now, you have a choice. You can go right to speed, or you can go to
So those are those
acceleration.
kind of
Well,
cool
your
ways you
acceleration.
can trigger those events out of here. But obviously Leonard's not doubling down in a psychological way that I would. He's not doing that. To put the term on it for him, I can't know the acceleration. I can't know for sure unless I've watched all the videos, seen Prime, and said he's looking for whatever word he would say enough times when it comes up to feel comfortable about that's what that is, and mathematically I bet you're like, Leonard, in your video. So those are the kind of things I want to note here. And so again, pay attention to the female and male aspects, and use this advantage of not looking at the students, because you're going to have your back turned. You're going to be in the stone pile. You're going to be in it like that. So that was the note I wanted to give you here, guys. Catch you on the next one.